Operations with scientific notation. Okay. So we've talked about converting from regular notation to scientific, from scientific to regular. We've talked about comparing scientific notation. We've talked about ordering scientific notation. And now we're going to do operating scientific notation. So your test over scientific notation will have all of those things. Okay, first let's talk about what an operation is. So when you hear the word operation in math, what do you think of? Give me an example, or what's the first thing that pops in your head when you hear the word operation in math? Plus or minus, so like addition or subtraction. What else? Yes, Grace. Problem. What else? What about when you hear the word operation not in math? What do you think of? Yes. A surgery. So I always compare, so surgeries are a way to change your body or fix your body, depending on what type of surgery it is. So an operation in math is a way to change a number. So I can add more to it. I can subtract from that number. How else can I change a number? Multiplication. Any other ways? Division. So operations are how we change numbers. So we're going to talk about addition, subtraction, multiplication, and division. They're usually written as a problem. The other ways that we can change other operations are like the root of something or the power of something, but we're not going to talk about those today. Okay, so when we are adding and subtracting, scientific notation, we're going to follow some certain rules. Okay, so before, I want you to make sure that you're writing what I'm writing, because I'm going to write the steps and then we're going to do the steps. Before numbers in scientific, ooh, that was wrong spelling. Oh wait, no it wasn't. Scientific notation, sorry I can't spell apparently, can be added or subtracted. The exponents must be equal. So I'll give you a chance to write that. So before we can even add or subtract anything, we have to make sure that the exponents are equal to each other. When I wrote this the first time, it was nice and neat, and apparently my hands aren't working today. Okay, so for example, we're going to do this example together. If I had 3.4 times 10 to the second power plus 4.57 times 10 to the third power. So I want to add 3.4 times 10 to the second plus 10.3 times 10, or sorry, 4.57 times 10 to the third. I made that a decimal. So before we can do that, we have to make sure that our exponents are equal, okay? So step one is to check if the exponents are equal. Are they equal? No, one is a 4 and one is a 2, or a 3, I mean. One is a 2 and one is a 3. So 2 and 3 obviously are not equal to each other. So we've checked that. So step 2 is to move the decimal to the left to increase the exponent. So remember, increase means go up, so we're going to increase one of the exponents. If I want them equal, and this one's 2 and this one's 3, which one am I going to increase? The 2. So I'm going to change the 3.4 times 10 to the second. I'm going to, if I want to get to 10 to the third power, so they're the same, I'm going to move it once to the left. So I want to move it once to the left to get 10 to the second to become 10 to the third. So now instead of 3.4 times 10 to the second, I have 0.34 times 10 to the third plus 4.57 times 10 to the third. Because if I changed, and you don't have to write this, but I'm going to show you. If I changed 3.4 times 10 to the second, if I changed that to regular notation, I'd move my decimal 2 places to the right. 1, 2, so it becomes 340. If I change 0.34 times 10 to the third to regular notation, I move it 3 places to the right. 1, 2, 3, so I get 340. Are those two things the same? 340 equal to 340? Yes, Mrs. Christian. So this and this are the same. All right, step 3. We're going to add the constants. Remember, a constant is a number that is always a number. So 0.34 and 4.57 plus 4.57. If it were me, I'd add them vertically, but I've already done that for you. So equals 4.91. And then, so I added this one and this one. Okay. And the last step is keep exponent number the same. So our answer is, we're going to take this number 4.91 times 10 to the third. So we keep it the same from step 2 when we changed it. I gotta sneeze. Okay. All right, I'm going to give you a problem of adding that I want you to do with a partner. If it was a subtraction problem on step 3, you would subtract, okay? And everything else is the same. Okay, so with a partner, I want you to do 1.2 times 10 to the 5th plus 5.35 times 10 to the 6th. Okay? I'm going to freeze it. When you are done, I want you to put your pencil down. So 1.2 times 10 to the 5th plus 5.35 times 10 to the 6th. You can work with by yourself if you want, but you can definitely move and work together if you'd rather. So follow the steps. Step 1, 2, 3, 4. When you're done, make sure you put your pencil down. Show me with your fingers if you need 1, 2, or 0 more minutes. Okay, let's do 1.5. We'll start with 1 to, I'll check in at 1 and see how we're doing. What? I'm checking with everyone at 1. What? Wait, I don't understand. I'm going to check in at 1 to see how we're doing. Is that better? Okay. Okay, does anyone need more time? Okay. All right, so I'm going to unfreeze and show you what I got. So I knew that I needed to move this back 1 to make it, I knew I needed to move the times 10 to the 5th back 1. Okay, so I moved it back so it became 0.12 times 10 to the 6th. And then I added 5.35 and 0.12, got 5.47, and then I kept my power and base the same. Okay, does anyone have a question on how I did that? All right, you're going to do plenty of practice the next couple of days if you're still a little bit confused. All right, so I should have done a subtraction problem, but I don't have one written down off the top of my head. I'll do one in a few minutes. But we're going to talk about multiplying and dividing too. So multiplying, I'm doing it on the back of my paper just because I ran out of the front. Okay. So when numbers in scientific notation are multiplied, only the number, which is also called the constant, so we're only going to talk about the constant first and then we'll talk about the powers, is multiplied. So we're only going to multiply the constant the powers are added. When we talked about our exponent and power rules, we talked about when we multiply two powers and two bases that are the same, we add the powers. So we're bringing those rules back into scientific notation and we're going to use those rules. So we are multiplying, but when we multiply exponents with the same base, we add the powers. So, for example, if we have 2.00 times 10 to the third times 4.00 times 10 to the 4. Whoa, I wrote the 4 instead of the 10. Times 10 to the 4th. So if you were given a problem that looked like that, there are only two steps. Step 1, you're going to multiply the constants. Remember, the constants are the numbers, just the numbers, not the powers and bases. So we're multiplying 2.00 times 4.00. What is 2.00 times 4.00? 8.00 or 8. I'm going to leave the same number of decimals. And then, so the 0.00s were there to kind of throw you off, but it's just 2 times 4. $2 times $4. Step 2 is to add powers. Base stays the same. So we have 10 to the third and 10 to the fourth. So I'm adding the 3 and the 4. What's 3 plus 4? So it becomes 10 to the 7th. So we take our answer from part 1, or step 1, and our answer from step 2, and that becomes our final answer. So our final answer is 8.00 times 10 to the 7th power. And it's okay if you dropped those zeros, but I'm just going to leave it with the 2 places after the decimal because that's how my problem was written, and that should be your guide. Like, however the problem was written is how your answer should look. Okay? Right, Nathan? Okay. With a partner, I want you to do 4.3 times 10 to the 8th. All of that times 2.0 times 10 to the 6th. So I want you to do that problem with your partner or by yourself. Check with a partner or do it by yourself. It doesn't matter, however you would prefer to do it. What the heck is happening next? Is that how he always is? Yeah. Show me with your fingers. 1, 2, 0. Sorry, 1 or 0, 2, 0, 0, 0. All right, I see all zeros, so I'm gonna project my answer. I got 8.6 times 10 to the 14th power. I did scratch work on a separate piece of paper, but I did 4.3 times 2.0, but if I have $4.30 in this hand and $4.30 in this hand, and I put them together, I have $8.60, okay? What questions do you have about that one? All right, division is our last one. It's also only 2 steps. It's very similar to multiplication, except we're going to divide. Dividing. You will have an assignment today, but tomorrow will be a work day, so I don't expect you to finish the assignment in class today. Just in case you're worried about time. All right. So dividing, when numbers in scientific notation are divided, the exponents are subtracted, just like the rules that we learned when we talked about exponent rules. And then only the numbers or the constants are divided. So we're going to do one example, 2 steps, very similar steps to the last one. 9.60 times 10 to the 7th divided by 1.60 times 10 to the 4th. Remember that a fraction bar just means divided by, and for probably the rest of the year, almost always it'll be written that way without this division sign, but that's what it means. Okay, so step 1 is to divide the constants. So we're dividing 9.60 divided by 1.60, which, if you think 96 divided by 16, I wouldn't know that off the top of my head, but I already did it, so it's 6. Okay, and then step 2, here, it's nice and warm for him.
Oh, right there.
Oh, okay. Step 2 is to subtract the powers. Just like our rules when we learned about exponents told us that we subtract our powers when we're dividing. But the base stays the same. So I have 10 to the 7th and 10 to the 4th. So I'm going to do 10 to the 7th minus 4. What is 7 minus 4? So now I have 10 to the 3rd power. So I take my answer from step 1 and my answer from step 2 and I put them together. So now I have 6 times 10 to the 3rd. Okay, with a partner, I want you to do 7.8 times 10 to the 3rd divided by 1.2 times 10 to the 4th. I'm going to freeze that. While you're doing that, I'm going to pass out today's assignment just so you can have it. It's hole punch. It has the wrong due date because I put the due date before thinking about what we were doing. Seven 7.8 divided by 1.2 is 6.5, just so you guys know. Okay, so when I did the division, I told you what I got. I got 6.5, but 3 minus 4 is negative 1. So you should have gotten 6.5 times 10 to the negative 1. And it's okay to just leave it written like that. You don't need to put it in a fraction. Does anyone have any questions on that one? Okay, so what I want you to do is start on that